All right. And Shane, I'm gonna stand right here with the headset in case there's questions. All right. We're the last thing for this part one of reactions is talking about energy in reactions. And I guess I need to back up though before we get to that. I'm about to forget. We always do the attendance. So let's go to modules. And then if anybody has a question, I won't be able to hear you for just a minute while I do attendance. I'll take my headphones off. All right, go down to the 12th. I'll try to hold it up here though. And we are balancing, and I'm going to try something, and we'll try to do it up here. I don't know if it'll work or not. Ooh, work or not. Back here. I want to pull this up. We'll see if I can write. Are you able to still see my screen, James?
Yes.
All right, if I write right here, do you see my writing? Or do you
No.
no? Fiddledy.
Mm-mm.
I thought it didn't work. Somebody was trying to tell me that it would work. I thought I had to do my whole screen. So let me share my whole screen. Oh, that's, yeah. So, oh, I got to get out of here. And it's good to have you on because now I'm going to figure out how to do this because I'm going to have a guinea pig here. So let me present again. This time I'm going to present entire screen. All right, so now if I do this and if I write, do you see my writing? Do you see a green squiggly?
No.
No. That's what I tried to tell technology that would not work. Okay. Well, piddledy. Yes, piddledy. All right. We're going to balance these equations. So as I do it, James, you can, in your text box, you can just write the numbers that we put, and you'll hear me say what to put. So up here at the top, if you will click, yours says submit assignment, click there to get your text box. And we're going to, even though I think I'll go back here, I'm writing up here and you can't see it, I'll tell you what to type in. So we're going to balance this first equation. So in the middle, I am going to put H. Notice that Cn is together on both sides. That's a polyatomic ion. So I'm going to keep it together. So I'm writing under the arrow H, capital C, capital N. Then I'm writing capital C, U, which is underneath it. And then I'm writing SO4 I'm keeping together because it is the same on both sides. So now I'm going to count. On the left, there's one H, one CN because there's no little subscripts. The CU is 1. The SO4 is 1. The 4 is a part of that SO4 unit. On the right-hand side, I have a 2 for H. SO4 is a 1. CU is a 1, but the CN is a 2. So to get it balanced on the left-hand side, I'm going to put a 2 in front of the HCN, and that is all I have to do to get it balanced. So for your answer for number 1, you will type number 1, you will put a 2, comma, 1, comma, 1, comma, 1. Oops, 1. All right. Then it says to classify. So if you look at this, H is one thing, CN is one thing, CU is one thing, and SO4 is one thing on the left-hand side. If you look on the right-hand side, you can see that the CU and the H um, switch places. They're now bound with the other substance. So H is with SO4 and Cu is with Cn. So this is considered double. So you're going to also write for number one double. You'll see that as double replacement or double displacement. So for number one more time, you're going to type 2, comma 1, comma 1, comma 1. So you should have a 2 and 3 ones and then the word double. Number 2, we have just N and H. So I'm going to balance it. On the left, there's one N, 3 H's. The right, 2 N's and 2 H's. I'm going to start with my N's first. So if I put a 2 in front of the NH, that means my N's are 2 and my H's are 6. And so to make my H is 6 on the other side, I have to put a 3 in front of the H2. So you're going to write for this one 2, comma 1, comma 3. And then notice I have one thing and it's breaking down into 2. That's decomposition. So you're going to also add for number 2, whoops, decomposition, if I will spell it right. All right. So then the third one, notice that I have an oxygen as a reactant and I have carbon dioxide and water as products. This is going to be combustion, so I can go ahead and write that down. Then we're going to, we have C, H, and O. So 2, 2, and 2 on the left. I have 1 carbon, 2 oxygens, and I like to put a second O here. One O has 2 and one has 1 for a total of 3. So now I need to balance. These are always the hardest to balance. I'm going to start with give me a minute to think. If I put, that'll be 4, 8, 9, 10. All right, I'm going to have to put 2 in front of the C2H2. So that's going to be times 2 for those. So that gives me 4 C's and 4 H's. So on the other side, I'm going to have to do times 4, 4 in front of the CO2. So my C's are good. The O with the 2 is times 4, so that makes it 8. My hydrogens, I'm going to put a 2 in front of the water. Oh, well, and that is going to give me 2 and 2 for the oxygens. So total oxygens is 10. I need a 5 in front of the O. So your answer for this one is 2, comma 5, comma 4, comma 2. Combustions are always the hardest to balance, and I wish you could have seen me work it. James, I got to figure out a better way to do that
Okay.
on here. I may have to record on my Chromebook from now on. All right. So, if you got those answers, submit. If you didn't hear them all, James, I will have it recorded again and you can listen for them. So you've submitted, right, Shane? All right. So let me get back out of here. Now we can see again. All right, we're going to talk about energy. So I'm going to go back to my little map here. So all chemical reactions exchange energy. They're either going to release or absorb energy. And there's some terms for this in the video that I have up. If I don't have it up, I will have it up. We'll use some terms that may not be in here, but the main thing is exothermic and endothermic are the two main terms that you need to be familiar with. So energy can be in several different forms. You've got light, heat, sound, or electricity. So anytime energy is released, it's going to be in one of those forms. So we're going to look at energy releasing first. There's two terms here, exergonic or endothermic. So exergonic is just any release of energy. It could be in any of those forms. Exothermic, because it has therm in it, is just the release of energy in the form of heat. So exergonic is the release of any energy type. Exothermic, the release of heat. So you need to know the difference there. And the same with endergonic is the absorption of any type of energy. Endothermic is just the absorption of heat energy. So got to know the difference between that. So exo is to exit, so it's release. Endo is to absorb or to bring in, so that's absorbing. So word parts are really important here. Reaction rate. So with chemical reactions, we can speed them up or slow them down by changing the temperature, concentration, surface area, add a catalyst, or change the pressure. So 5 ways to change reaction rates. So we're going to look at temperature first. So, higher the temperature, the faster the reaction. I like to use the scenario if you were to walk across a bed of hot coals, are you going to go slow or are you going to go fast? Probably go fast because it's a hot, hot temperature. So, if the temperature is increased, it's going to cause the reaction to go faster. But there's more particles moving, they're going to collide, so they're going to come in contact with each other. So, increased temperature, faster reaction. Concentration, that means how much of the different substances. So, how much of the reactants are there? So, the more you have, the more chances that they'll come in contact with each other, the faster the reaction will work. So, concentration higher, the concentration faster the reaction. Now, surface area. The smaller the particle, the faster it'll be. If you have a sugar cube and you drop it into your hot tea, it's going to take a little while for it to dissolve. But if you put a spoonful of sugar, it's going to dissolve quicker. So it's got a greater surface area the smaller the particles. So that will increase reaction. Notice we're mainly concerned about increasing reaction rates. Catalyst, if you've had biology, we've talked about enzymes as a catalyst. They're going to speed up reactions because it lowers the amount of energy needed for the reaction. Catalyst will not be used up. They're just going to help that along. So, in yet the other day when we looked at the elephant toothpaste, the potassium iodine was added to soap and hydrogen peroxide when we made the elephant toothpaste or when we saw that video. And so that was kind of a catalyst. It helped that reaction take place. Pressure. Higher the pressure, the faster the reaction. So this is only gases as reactants. This is only going to involve gases as reactants. So higher the pressure, the less volume, so you're going to have more collisions. All right. So that's pretty much today's the concepts for today. And then let's see what we have listed. I may not have anything but a video if I did put the video on. Let's see what I did. Um yeah. So basically all you have for today is a video Then I want you to actually work on getting makeup work done after you do the video. And then we're going to, tomorrow, you need to go through the Kahoots. Monday in class, we'll go through some type of review, depending on how many students I have here. And then Tuesday, I plan on you guys doing the test for part one. We may do it Monday, just depending. Any questions, James?
Mm. So the assignment for Tuesday?
The assignment for today
Yeah,
is
the
just
video.
the video, energy and reactions, which kind of goes along with what I had said, because there's really not a lot that we can do with this
Mm-hmm.
remotely. And then go back and work on your makeup work, okay,
Okay.
or things that you haven't done. Tomorrow, you need to sign on and do the attendance. And then I've got a Kahoot that I've already made live for you to start practicing with. And so you need to make sure, especially everything in the reactions unit,
Okay.
would be good if all of that is done so that you can do well on the test. And we may test on Monday. I'll do a review with the Kahoot and then
Okay.
test on Monday. So if you pop in on Monday, that'll give me a second student to for guys to play with because I normally just have one student here. And then we can do the test, and then we're going to move in next week to our next topic with
Okay.
reactions.
Can Miss Noel, can you he had questions about the um James, what was the assignment? The
For
RXN one.
The which one?
It has right there practice balancing classifying chemical RXN.
Uh huh.
Can you do like a few examples?
Let Give me just a minute to get my Chromebook. Hold on.
Okay, that's fine.
All right, I'm gonna do a tutoring session here. Got videos to do makeup work. All right, I have to stop presenting on my big thing TV and get to my Chromebook so I can write. This is kind of, I got to figure out how to record where my writing shows up. Um, well, let me get to Google. Guess it would help if I log in. Um,
Is Almaro getting a lot of rain, Noel?
yes.
Yeah.
I'm
Okay.
surprised. I guess it's because we were going to get out at 1 since they're calling for flash floods, but oh, of course, I've got to log in.
You
Just
guys are
one.
getting out early? Is that what you said?
Yeah, and then I remember, oh, yeah, we already get out. We get out at 1. So
Let's well,
79172764. You know how it floods here
yeah.
around the academy.
Well, it's flooding where I'm at now.
yeah, my little creek down the street's flooded.
Yeah, my driveway looks like a creek.
All right. Slowly, slowly. I'm getting. There has to be a way that they can see what I'm doing on my big board in my classroom. It's irritating
You
me.
got a little creek in here.
Yep. Okay. Uh, all right.
Yeah.
So you'll see two of me. Oh, oh, I gotta mute this one. Okay, now we don't have that echo. I don't think. Well, trying to use my mouse. All right. So, oh, I needed to present. Dang it. All right. Let me just Am I echoing to y'all?
No.
Okay. I guess I don't have to record this, so hold on.
There's a little bit of echo, but it's not too
Well,
bad.